Cancer impacts us all. Everyone knows at least one person that's been affected by cancer, including myself. As a postdoc at Stanford University, to a stint at Genentech in the Cancer Immuno-Oncology Department, to now my time at Clearlight Biotechnologies, what we know is that the failure rates for immuno-oncology research remain high. At Clearlight, our goal is to capture and minimize these risks and failures at the preclinical stage of research. Hi, I'm Dr. Charlotte White, the Vice President of Research and Development at Clearlight Biotechnologies. Today, we're going to discuss how we're creating new opportunities with our Clarity technology to address the high failure rate associated with immuno-oncology research. There is still so much we need to learn about the tumor microenvironment. It's still very much the Wild West in there. What do I mean when I say it's the Wild West? Well, we've made assumptions about what happens with cancer and in tumors. We talk about the adaptive immune system, escape mechanisms for tumors to protect themselves. Often using 2D or common gold standard approaches, these things can be missed. When you start to look at these in the 3D aspect, we start to get a lot more insight into what we don't know about what's going on. So who's in our neighborhood? Well, we've got a wide cast of characters. We've got bad Bart, our cancer cells. We've got macrophages, T cells, B cells, NK cells, and endothelial cells. Fibroblasts and adipocytes can also contribute. How do you confirm who you are seeing in the neighborhood? Biomarkers specific to individual cells or multi-labeled cells, which can further identify cells such as T cells, if they're CD4 or CD8, can be used to identify the various cell types that are present. So within the microenvironment, we've got our cancer cells, the T cells, which can be memory T cells, cytotoxic T cells, regulatory T cells, or exhausted T cells. Then you happen to have macrophages. These are our shapeshifters in the Wild West. They can be pro-inflammatory or anti-inflammatory. They're very much impacted by their environment, and that allows them to either be helpful or they can become the villains in this story. What role do these supporting characters play in what's going on? We have the endothelial cells, which are going to make sure that the nutrients via blood flow are flowing into and out of the tumor. This can be great for bringing treatment in. It could also be great for helping out the cancer cells because they're able to get what they need from the surrounding environment. How much they impact or affect what is going on is unknown. You have cells that are going to cause secretions, again, that can affect the environment. Our alpha smooth muscle actin cells tend to secrete into the environment. Solid tumors like PDAC, pancreatic adenocarcinoma, have a lot of supporting cast members that play a role. The development of connective tissue can help fortify the tumor and be more of a hindrance than a help in the process. These are all big, huge unknowns and how they affect the highways. And by highways, we mean the cancer highways to vascularization. So who is hiding out? Who is coming to town to help or hurt? This is the early stage advantage that tissue clearing and 3D imaging can provide to you in your research at the preclinical stage. Clearlight gives researchers an early advantage. This is important before you get to the expensive and high-stakes world of clinical trials. So what does it mean to have an early advantage? Imagine being able to see the tumor microenvironment in 3 dimensions. You're able to identify cell boundaries, vascularization, cellular apoptosis and necrosis, and the spatial orientation within that tumor microenvironment. Imagine being able to see if the immune response is being activated as a result of your experimental treatment. Is it performing as designed or intended, or are you not getting the result that you expect? Our expertise in thick tissue antibody penetration gives researchers that ability to demonstrate if a given therapy is penetrating the tumor core. Imagine having all these insights at your fingertips. This is the early advantage that Clearlight offers preclinical immuno-oncology researchers in academia and commercial environments. Originally developed at Stanford University by Carl Dazeroth and colleagues, Clarity Tissue Clearing focuses on removing light-scattering lipids from brain tissue. At Clearlight, we're working to expand clarity beyond the brain. Clarity is a core part of our lab services. Clearlight has evaluated normal and cancerous tissues, including lung, pancreas, colon, brain, tonsil, eye, skin, and more. Our 2019 publication on breast cancer is a great example of this. In addition to Clarity tissue clearing, our lab services include thick tissue immunostaining and true 3D tissue analysis. After tissue clearing and immunostaining, we provide the data in two formats: the standard 2D slice view as we played through the Z-stack, as well as a 3D volumetric rendering that rotates the sample. This provides critical context that can't be seen using the gold standard 2D FFPE methods. We use either confocal or light sheet microscopy, depending on the tissue type and the research questions involved. We are continuing to develop our true 3D software capabilities that show cell segmentation and spatial analysis. All of these tools that are a part of our lab services are designed to give researchers a better and deeper understanding of the tumor microenvironment. So let's look at a few examples. We'll revisit an example of the breast cancer tumor from our 2019 paper. In green, the tumor is outlining the epithelial cells. In yellow, we're looking at the nuclear marker Ki67 that's going to denote proliferation, and our red channel is demonstrating the CD3 T cells. As we rotate through the volume, you can see that there are clear areas of both co-localization and individual cells as they make their way through the tumor at this fixation point. As we rotate through the 3D volume, we can see that the tumors and various smaller metastasizing cells are located throughout this particular field of view. We're going to transition to the slice view, and now we can see clear epithelial markers and boundaries by the pancytokeratin, as well as cells that are proliferating with Ki67. The ability of our technology allows you to easily convert between a 2D slice view and a 3D volume view. Our next example is going to be a glioblastoma from the GL267 mouse syngeneic tumor. What we can see when we rotate the volume is that there is a clear immune response that is occurring. And then as we start to turn off the channels, we can see that CD3 is present throughout this entire field of view. We turn on the green channel, which is alpha smooth muscle actin. It clearly denotes the vascularization that's occurring in this sample. What we would like to note is in the brain, alpha smooth muscle actin cleanly lines vascularization, and we don't see as much secretion by the cancerous tumors. Here we are going to look at a Hep55 syngeneic mouse tumor. This is a good time to point out that liver tissue notoriously has a high autofluorescent background. Here at Clearlight, we have worked to optimize the clarity and 3D IHC technique to account for the increase in background, making sure that once we capture these images, we're able to show you true signal away from an increased background that may occur within liver tissue. As we rotate through the volume of this tissue, you're able to see that there's a high presence of F480 macrophages demonstrated by the red channel. We see that there's a tumor boundary as well as vascularization demonstrated by the green channel, and then of course, the DAPI nuclear counter stain in blue. As we continue to rotate this sample, evaluating the tumor in all of the different directions that are available to us, we can see that there is a congregation of macrophages on one side of the field of view. And while there are macrophages on the other side, what we can infer is that the tumor boundary appears to be hindering the ability of the F480 macrophages to penetrate into the tumor. One of the key aspects that you would be intrigued by with your treatment is, one, is it triggering an immune response? Is it triggering your desired immune response? But also, once that response has been triggered, are your immune cells actually getting to your target? And in this case, what we can see is that we've triggered the immune response, but we're having a limited effect into the actual tumor. This can be a great early advantage for you to determine at the preclinical stage. So what does the early advantage look like specifically when we're talking about preclinical research? You have your isotype control, very heterogeneous mix. This establishes the baseline for what's going on in your study. Treatment one is a known treatment. In this case, we see that it's causing a response. In this case, we'll call them CD8 T cells. They're being attracted to the tumor. However, they're not actually penetrating into a tumor, creating a cold tumor. Your drug, treatment 2, is also causing an immune response. The CD8 cells are congregating on the outer layer of the tumor and they're starting to penetrate, but the tumor is still cold. Now you do a combination treatment where you've got a known treatment plus yours. And what we can see is not only are the T cells congregating and increasing in number, but they're actually fully penetrating into the cell. And now our tumor has gone from being cold to hot. This combination and being able to see the actual spatial representation and orientation of where your T cells are, in addition to a count, some quantitative number, give you greater insight, thus creating an early advantage for your preclinical research. Another way to think about the early advantage when we start talking about specific treatments will be to focus on treatment 2. You've developed a drug target, and now you want to know how specific or non-specific your response is. Your drug is causing a response. You're seeing an increase in the CD8 T cells to the tumor. But now, once they get inside the tumor, what's occurring? Are your T cells sharpshooters, specifically gunning for the cancerous cells and allowing all of the other immune cells helping with the response to continue to aid? Or is your treatment a stick of dynamite, non-discriminatory, destroying everything in its path, which, while helpful in regards to the tumor, may be detrimental into saving our Western town? At this point, I'd like to introduce Amy Lamb, our application scientist here at Clearlight. She is often the first point of contact for our potential customers and clients. So Amy, what are some of the common questions that you hear from customers when they first reach out to Clearlight?
Definitely. So a lot of customers are interested in specific biomarker or tissue combinations. So the most common question that I get is, have you done this combination before? We generally say that Clarity can pretty easily be applied to most soft tissues. If the tissue is pigmented or is hard, like if it's calcified, for example, it does take some pre-processing, but in general, we think that, if we haven't worked with a tissue biomarker combination before and you really want to pursue this, then it's a good time to do a pilot project where we establish feasibility for your particular biomarker or tissue combination.
Amy, that's an excellent point. With pilot studies, this is often a great time for customers to establish if Clarity is going to be a good fit for the projects that they're interested in. It's an excellent way to determine antibody feasibility or optimization for new markers that might be relevant for their research that we might not have listed yet. It's also a great time for us to try out new tissues that we don't have previous experiment with or that are currently in development as we try to refine that process in cases such as melanoma and the eye. And Amy, what do you say if a researcher wants to know more about the Clarity workflow and what's involved in the process?
Well, we have a lot of great resources on our website. Our website has infographics on the Clarity workflow, which shows each step. We also have a lot of videos available there and also on our YouTube channel. We also do on our website have the papers that were published from the original Clarity protocol that can serve as a great resource for people to refer to as well.
Amy, thank you so much for your time and helping us understand what all is involved with the Clarity workflow process. We hope you've enjoyed this exploration of tissue clearing and 3D imaging and how it can create new opportunities in your research. Please visit us at clearlightbio.com/leverage and leverage our expertise for your research.